Today's lesson is direct variation. Our objectives is to write an equation of a direct variation and to use ratios and proportions with direct variations. Some vocabulary you need to know for direct variation. A function in the form y equals kx. So this time k and x are multiplying. One of our other lessons, it's going to be dividing, so I want you to notice that k and x are multiplying on this one. K cannot equal 0 in a direct variation. The constant of the variation for direct variation is k, so this is always going to, k will always stay the same. So let's go over some problems. Example 1. Is each equation a direct variation? If it is, find the constant. So first of all, we need to get y by itself, and then we can discuss it and see if it works. So to get y by itself, first of all, you need to get 5x away from 2y, and so that means I'm going to subtract 5x to both sides. So it's 2y equals negative 5x, and then I divide by 2. So y would equal negative 5 halves x. I would do it like that. Now, for you to remember direct variation, you have y equals a number times x, and nothing else attached with it. So I have y equals, so that works, a number, which is negative 5 halves, that works, and x, so yes it is. And here it is, the answer. And if it says find the constant of the variation, it would be negative 5 halves. And that would be your constant of the variation. Okay, let's try B and see if it works. Again, I need to subtract 5x. So I have 2y equals negative 5x plus 9. Then I divide by 2. So it would be y equals negative 5 halves x plus 9 halves. Now, again, we have to look. We have y equals, that works, negative 5 halves and k, they go together, and x goes together. But this one has an extra. So because it has this 9 halves, it's a no. So I'd like you to try C and D by yourself. Please put me on pause, do the math, and see if you got it correct afterwards. Alright, for C, I have, after I did all my math, was y equals negative 4/3 x plus 8 over 3. And because of the 8 over 3, that's extra stuff we do not need to have, so it's no. And then you have D, I have y equals 2/7 x. And that would be y equals kx. That's the same idea. So yes, it is. And my constant is 2/7. All right. Next, this has 2 steps to it. Step 1. Write an equation of direct variation. So first of all, we need to find k. So step 1 is find k. So again, the formula is y equals kx, and we're trying to find k. So another way we can look at this is I'll do all different colors. Y, then equals k, And then X will make blue. And if you look at the points they give you, right here on A, X is the 4, and Y is the -3. So you're going to plug it in those spots and find out what K equals. That's just step 1. So I'm going to do -3 equals K times 4. And then I want to get rid of everything attached to the K, which 4 is multiplying, so we're going to divide. So K equals -3/4. Okay, now we're going to plug it back in, and you're going to plug it back in for this one. So the only number you're going to have on your answer after you plug it in is the K. So here is your full answer that you need. Let's try B. That's your Y. So -6 equals, and then K times, and then your X is -3. All right, then I divide by -3 because it's multiplying. So K equals 2. Now I'm going to plug it in to this equation right up here. So it's going to be Y equals 2X. I would like you to put me on pause and try C and D by yourself. So C, you would have Y equals 2K, and D would be Y equals -1/3 K. So if you didn't get them correct, make sure you go back and try it again and see where you might have plugged the numbers in wrong. Okay, example 2. Define the variables, then write a direct variation to model each relationship. Okay, so again, Y equals KX. So Y directly varies with X. Varies directly with X. So let's look at it. Whether your distance from lightning varies directly with the time it takes you to hear thunder. So if I look at it, it says distance varies directly with time. Okay, so if I look here, it says Y directly varies with X. So, distance. The distance is, let me read it. If you hear thunder, 10 seconds, so that's time. After you see lightning, you're about 2 miles. That's distance. From the lightning, write an equation. So, I have distance varies directly. So distance is 2 miles. Direct varies directly with time. So time is 10 seconds. So I need to find K first. And now we're going back to example 1. Or example 2, I'm not sure which. No, example 2, sorry. So then I divide by 10. So K equals, and I would reduce it 2/10 to 1/5. Now I can write out my equation. Y equals 1/5 x. And that's how you would do it. So let's look at B. A recipe for a dozen corn muffins. So dozen means 12, right? That's the number of muffins. Calls for 1 cup of flour. The number of muffins varies directly with the amount of flour used. So let's look at it. The number of muffins is 12, because it's a dozen, equals K, and then amount of flour used times 1. Because there's only 1 cup of flour used, right there. So then I divide by 1. So K equals 12. Now I can write my equation. Y equals 12, not K, 12x. And that's how you would do that. All right. Example 4. For the data in each table, tell whether y varies directly with x. If it does, write an equation. So, I'm going to tell you another way of finding x. K. So the formula we're going to use on this one is K equals y divided by x. And when you do your dividing, you want to make sure all the answers are correct. So if we start with the first table, we're going to take y, which is 2.25, and divide it by -3. Same idea with the second one. You're going to take y, which is -0.75, and divide it by 1. Same on this one, -3/4, and -4.5 divided by 6. And you're going to do the math and see if it works. So you do it and you go 2.25 divided by -3. That equals -0.75. -0.75 divided by 1 is -0.75. -3/4 is -0.75. And -4.5 divided by 6 is also -7.5. Now, if it is, all of them are the same, which they are, you're going to say yes. And then you're going to write the equation. You're going to write y equals -0.75x. Because that is your constant right there, the 0.75. Let's look at B. -1/2. If we did it in decimal form, would be -0.5. And then B, the second one would be 1/4, which is 0.25. Well, immediately right there, that tells me they don't have the same number, so you would say no, because they don't direct vary. All right. The force you must apply to lift, sorry, that's not left. Lift an object is proportional to the object's weight. You need to apply 0.625 pounds of force to a windlass. It is windlass, something like that. To lift 28 pounds. Write an equation and find how much force you would need to lift 180 pounds. So 100 pounds. So first you're going to